So we're going to be reviewing compound inequalities, which is just inequalities with a little more complications. So let's review really quickly how the inequalities are utilized and read. We have inequalities that are less than, which means a number in front, whatever this number may be, should be less than or smaller than the number behind it. We have greater than. The number in front on the left side should be larger or greater than the number to the right. And again, just to emphasize, this is a short way, or this is rather, keep in mind that whatever your native language is, and in this case, I'm speaking in English, so we're assuming it's English, we are changing the words is in English, and this is in math language. Math has its own language, and this is part of it, and part of it is learning that vocabulary. So this is the less than, and that's the greater than. It's a lot quicker to just write these symbols than to write those words out. Now we also have less than or equal to. And the only difference between this and this is this has a little sign underneath, right? A little dash, just like half of an equal sign. And it means the number to the left is smaller than or equal to, less than or equal to the number on the right. And just like the greater than, we have greater than or equal to. This symbolizes the equal to sign. The number on the left is greater than or equal to, is larger than or equal to the number on the right. That's how we read it, and that's how our final answer is going to be. With compound inequalities, we're going to have two answers for the most part, 99.99%, right? 99.9999%. Anyway, so how do these compound inequalities look? Well, they generally have two inequalities, and they're separated by and or. When they're separated by and, what it basically means is you are going to get two number lines. And keep in mind, whenever you just have one variable, you're going to create a number line. So if you have one inequality and another inequality that you solve, you're going to look, that and signifies what do they have in common? Where do they overlap? What numbers do they share? Though from one inequality and another inequality, what do they share? And that's kind of, you have to understand that. So we're looking for what do they have in common? What do they share? When we see the word and. And if we see the word or between two inequalities that they're flat out, they say what they are, or you have to solve them, it means the answer could be in one or the answer could be in the other. So they usually look like two arrows going in opposite directions, and your answers work if they're here and your answers work if they're there. They could work in one inequality or both, or the other one. It doesn't have to be both. The and has to be the solutions that work in both. The or can just be the solution that works in one of the two inequalities. Not both, but just one of the two. So how does that actually look like? Well, to give you an example, we have example 1 here, right? And example 1 shows -4 plus x less than or equal to 10. We want to solve for x, or x minus 4 greater than or equal to -4. Again, we're going to solve for x over here. And that or is my signal saying I probably have things that are going in opposite directions, right? And the solution can be either what's on one inequality or what's on the other. So let's solve for x. We have -4 plus x, so I'm going to add 4 to both sides of the inequality. I get 0 plus x less than or equal to -10 plus 4. That's like saying I owe $10 and I have 4 to pay it back. If I pay back with my 4, I still owe 6. 0 plus x less than or equal to -6. Notice I did not flip the sign because I didn't multiply or divide by a negative number. And I just added 4 on both sides. So I'm going to do this one in blue, and that says x is smaller than or equal to -6. I'm going to go to -6. I make a circle. If there's an underline there, I fill in that circle. And my x is smaller. Whatever number will work here has to be smaller. See how that pointy is? X is less than or equal to -6. My numbers smaller than or equal to -6 are in this direction. Okay? Now let's use a different color so you can see the difference. Let's do gray. All right, I still want my x alone. And I'm going to add 4. Oh, I don't like that too much. It's a little on the light side. How about if I use purple? Plus 4, plus 4. Okay, negative 4 plus 4 is x plus 0 greater than or equal to negative 4 plus 4. I owe $4. I have $4 to pay. If I use my money, I don't owe and I don't have. I'm at 0. I'm broke, but at least I don't owe money. X plus 0 is x greater than or equal to 0. How does that look? Well, the number that works here has to be larger than or equal to 0. So I go to 0. Here's 0. There's a line underneath. I color it. All the numbers that are larger than 0 this way. And you can see the classic form, absolutely classic form of the OR. You have solutions that go in one direction and solution that goes in the other. Any of these, one or the other, your solution could be found in one or the other. That's how you know it's compound inequalities with OR. Okay, so that is example number 1. Now let's go to example number 2. Okay, let's see. So example number 2 looks something like this. Okay, well, let's make that a little bit better to see. All right, so example number 2, we have and. And looks a little bit different. If we look over here, right, my and is where they overlap is what we're going to look for. So, and if they don't overlap, guess what? There's no solution. So let's see if this one overlaps or not. Okay, so here goes. I'm going to write this out. First one, I'm going to do blue. V divided by 8 is greater than negative 1. Okay, V divided by 8 greater than negative 1. I need to get my V alone. What's going on there? It's V divided by 8. The opposite of division is multiplication. And what I do to one side, I have to do to the other. Did I multiply by a negative number? No. So I don't flip the sign. 8 divided by 8 is 1 times V greater than negative 1 times 8, negative 8. Still haven't flipped it because I did not multiply by a negative number. 1 times V is V greater than negative 8. Okay. And actually, my number line doesn't have negative 8. So I'm going to have to add a few numbers here. Negative 9, negative 10, negative 11. Now, I usually recommend when you make the number line, and I did them ahead of time because just to save on time, is kind of look at the number before or after what you actually get in your solutions here. And then that kind of gives you a guideline on what you want to do. So let's see what happens over here. We have, this is going to be an and problem. And means I want to look at what they have in common and together. Where are they together? So 5V less than or equal to negative 25. I divide both sides by 5 because it's 5 times V. I do not flip this sign because I did not divide by a negative 5. 5 divided by 5 is 1 times V. Negative 25 divided by 5 is negative 5. V is less than or equal to negative 5. Where's my negative 5? Okay, here's my negative 8. Now this is and, right? Let's start the blue. V is larger than negative 8. Here is negative 8. Open. Not a line underneath here. It's larger. My larger numbers are this way. Okay? And they go that way. Now V is smaller than or equal to negative 5. I go to negative 5. Okay? And I'm going to put it on top here. Negative 5. Is it an open or closed circle? See that right there? That tells me closed circle. And it's going to be the smaller numbers to negative 5. The smaller numbers are in this direction because as you get larger negatives, it's actually smaller. What do they have in common? Well, right here. Now, what is actually in common? Well, 5 because it's circled. 5, everything in between 5, negative 6, negative 7. 8 is not included here because V has to be larger than or equal to negative 8. So from 5 up to just a tiny, tiny bit before negative 8. You can't see it so much with the circle, but anything just before negative 8. From negative 5 to anything just before negative 8, you can see where they overlap. That's always an and, the overlap. And if there's no overlap with an and, guess what? No solution. Now, and could be written as a word, or guess what? It could be written as something like this. Now take a look at this inequality. You have, it looks like one big old inequality. And basically what it is this here and that there. Okay, now some people like to figure it out all as one piece. That's perfectly fine. I like to separate them. That's me. So I'm going to show you how we separate them. And basically it's you take the first two and you write it out. -9 minus 6x less than or equal to 5x plus 2. And you take the second one. 5x plus 2 less than or equal to 8x minus 7. So basically we break it apart. And what we want to do is we want to find, when we see it like this is an and question. We want to find what they have in common. And it kind of feels that way, right? Because they're sharing that middle ground. We want to know what they share. What are the solutions that they share, right? Let me see if I can fix this a little bit so it's a little better. Okay, cool. All right, so let's figure this out. We have a variable on each side. I highly recommend, because this is an inequality, we move this one over, even though it's positive and that one's negative. But just because with inequalities, people get funny, they make mistakes if the x is on the other side. So let's start with -5x, -5x. Okay? -6x minus 5x. I like to think of it as I owe $6, I owe $5, I owe $11, and I better not forget the -9 in front there. Less than or equal to, I have 5, I owe 5. If I use my 5 to pay my debt, I have 0x plus 2. What is 0x? 0 plus 2. -9 minus 11x. Okay, we got to keep going. I hope we have enough space here. All right, this gives me 2. Now, I'm going to move this 9 over. So I'm going to add 9 on both sides. -9 plus 9 is 0 minus 11x less than or equal to 0 plus 2 plus 9, which is 11. And I get -11x less than or equal to 11. I'm going to finish that over here. -11x less than or equal to 11. I have to divide by -11. To get that x alone. That's been my goal all along. That's why I put them together over here. When I divide by 11, I must flip the sign. This gives me 1x, -1. X greater than or equal to -1. Now, my expectation, because this is sharing the middle, is there's going to be an overlap. See how this overlaps? It's sharing the middle. There's going to be an overlap. And if it isn't, again, drum roll please, it's no solution. So let's try this blue one. Okay. I'm going to move my x's. I'm going to move this over here because the x's here just is a little easier to deal with. -8x. I get -3x plus 2 less than or equal to 8x minus 8x is 0 minus 7. Now I'm going to move this 2 over, right? -2, -2. I haven't multiplied or divided by a negative number, so there's no flipping. This gives me -3x plus 0 less than or equal to. Now 0 take away 7 is -7. And take away another 2, -9. Or I have no money. I owe 7. I owe 2. Guess what, guys? I owe $9. -3x less than or equal to. Did I flip it? No, I can't flip it yet. I haven't multiplied or divided by a negative number. -9. Now I divide by a negative number. Ta-da! And it gives me 1x flipped greater than or equal to 3. That's x greater than or equal to 3. Now, I gotta squeeze that in. Let's see if I can do that. Okay. Look at my numbers. I have -1 and I have 3. Guess what, guys? I'm going to start at 0, and I'm going to make these a little bit larger. This would be 0, -1, -2, -3, right? Now, look at my two numbers. I have -1 and 3. I really don't need to go much more on this side, right? Because these are my numbers I'm dealing with, -1 and 3. The other ones, I just did a generic line. So this would be 1. Whoa. Okay, this would be 1. This will be 2. This will be 3. That will be 4. And we'll go 5 and 6. I made my number line based on these two numbers, a few in front of the smallest one and a few behind the largest one. X greater than or equal to -1. I'm expecting an overlap. Remember, here's -1. There's an equal sign. Color it. The numbers that are larger than -1 are in this direction, guys. Okay, there they are. Now, x is greater than or equal to 3, right? Okay. Let's see. Did we do anything wrong here? Okay. Which are greater than or equal to 3? Here's 3. I'm going to put a circle. And what numbers are greater than or equal to 3? Okay. What do they share here? They share these two. Now let's double check that we did this right, because it's making me a little nervous. 5x minus 8x, negative 3x plus 2. 8x minus 8x, 0 minus 7. Subtract 2, negative 9, negative 3x, divide by negative 3. And we flipped it. X is greater than or equal to 3. X is greater than or equal to negative 1. Yeah, that's right. So what do they share? Everything here till infinity. That's our solution. From 3 to positive infinity. Because 3 is included because it's a closed circle. Most of the time, though, you usually get something that's overlapping like this. This just happens to overlap in this direction. It happens sometimes. Okay, that's example number 3. And we think we have time for one more. So this is an or question, and it's important that we see an or. An or question means it could be one or the other. So we're going to do the same thing. We're going to solve both separately, and then we're going to see how the graph goes, right? Okay, so let's do that. I'll do this one in blue. M plus 3 less than or equal to 6. I subtract 3 from both sides. M plus 0 less than or equal to 3. M less than or equal to 3. I'm going to put this on the graph. 3. Closed circle because of that line. And it's less than or equal to all the numbers smaller than or equal to 3. This direction. Okay. The or means it could be one line or the other. I don't have to find the solution being what do they share. It's one or the other. The solution can be here. Now let's see where the solution can be on the other one. Negative 1 plus m greater than or equal to 4. I'm going to add 1 on both sides. I didn't flip here because I didn't even multiply. M greater than or equal to, and actually plus 0, 5. M greater than or equal to 5. So where's my 5? Closed circle, all the numbers larger than 5, that way. And you can see the solution works. If it works on this purple line, great. And if it works on this blue line, great. It satisfies what you're looking for. The answer could be here or there, but it doesn't have to be both. And that's the difference. And has to be both. What do they share? Or it could be what's on one or what's on the other. And that is compound inequalities. I guess the hardest part is if you have a slightly complicated inequality to figure out. But just remember, it's the same thing as solving as an equation. But if you multiply or divide by a negative number, you must flip the sign. That's the one major rule. And you make a number line. Remember, the and is overlap and the or is all together. Okay, so good luck. Enjoy your practice problems, and I hope this helped.